All right, today I'm going to wrap up Chapter 11 looking at the phylum Chordata. Phylum Chordata means that, well, basically they're vertebrates, but it's a little bit more technical than that. So I'm going to talk about characteristics that all chordates have, and then transition into vertebrates, and then talk about the many classes of vertebrates, like fish and amphibian, reptiles, birds, and mammals. But I'm not going to get through all of it today. I'm going to break this section up into two parts, just so that we spread it out a little bit here. But first off, what are the characteristics of chordata, or the chordates? So a chordate, by definition, is an animal that has a nodal cord, a nerve cord, a tail, also maybe known as a postanal tail, and then pharyngeal pouches at some point in its life. So if an organism has all four of these features at some point in its life, maybe it disappears, maybe it's only found in the juvenile stages, or maybe it's only found in a mature stage, then it's going to be considered a chordate. But like I said, as long as it has all four of these somewhere in its life. So what are these features? What is a nodal cord? So a nodal cord is a flexible rod-shaped structure that supports the body of a developing chordate. So I got a picture on the next slide that will show these features. The nerve cord is going to turn into the central nervous system. And then the pharyngeal pouches are located between the mouth and the digestive system. And so like for ours, our pharyngeal pouches tend to turn into like the eustachian tube, which is a tube that connects your ear to your throat. In other organisms, their pharyngeal pouches might develop into gills. And so these pharyngeal pouches can turn into different structures for that organism. So I know that we only went through 3 characteristics. This picture's showing 4 because it's kind of emphasizing the nerve cord as well as the postanal tail. But the nodal cord, as you can see at the top, number 1, long flexible rod, found in all chordates. In vertebrates, it's replaced by vertebra, which are the bones that make up the backbone. Okay, moving over to number 2, it says something that forms the spinal cord or the nerve cord. Number 3, bottom left hand, muscle and skeletal elements provide propulsion forces for the postanal tail. And then we have our pharyngeal slits or pouches. So most chordates are vertebrates. However, there are 2 groups that are chordates, but they are not vertebrates. They are considered invertebrates, and they are the tunicates and the lancelots. The tunicates are the top 2 pictures here, and in this cartoon diagram, in their larval stage. Okay, so like their young, immature stage, they are free swimming and they contain the nodal cord, the nerve cord, and other chordate features. And so because of that, they are considered chordates, even though they do not have a backbone. The other group, the lancelots, pictured on the bottom right-hand corner, have a lot of features that the chordates have, except no vertebra. Moving on to characteristics of vertebrates. So all have a vertebrae or a backbone, the bones that make up the back. And I should actually stop saying bones because sometimes they can be made of cartilage. And I am seeing that I have a typo for number 1. Awesome. Series of structures that surround and protect the nerve cord / spinal cord. So our vertebra, our backbones, they actually have like a tiny little tunnel in them that allow the nerve cord to be protected. But sometimes, that can be damaged and can result in paralysis. So the bones that form the vertebrae, the vertebrae are called vertebra. Okay, and we have lots of them. In fact, if you take anatomy class, your spinal cord is actually broken down, I think, into 5 sections, like the thoracic and lumbar and the cervical. Maybe it's just 3. I don't know. But another characteristic of vertebrates is they have a well-developed organ system, a digestive system that has 2 openings, which means a mouth and an anus, and then a circulatory system that's very sophisticated, as well as nervous systems. So, like a brain and a nerve cord. Okay, so I'm just going to talk about 2 groups the first two of the five. Fish. Their common characteristics is that they have gills, and the purpose of the gills is to absorb oxygen gas from the water. The gills are very filamentous to increase surface area so they can do diffusion of gases. They also have paired fins for swimming. Now, there are three classes of fishes. We have the jawless fish, which basically they're like tiny little vacuums. They don't have jaws. They just have these openings, and they just go around and suck up things for their food. So hagfish and lampreys are great examples of jawless fish. We also have the cartilaginous fish, which means that their skeleton is made up of cartilage, not bone. So sharks belong to this category. And then finally, the third class is the bony fish. So their skeleton is not made of cartilage, it's actually made of bone. And so some examples there, trout, guppies, and perch. So I have a short little video that goes through and gives out some examples, if it will let me. And again, hopefully YouTube will let me. Otherwise, the link is right there.
Welcome to Nodal Cord Science. In this video, I would like to talk about types of fish. There's a large variety of fish. Fish belong in the animal kingdom, or in the phylum Chordata. In addition, fish have a nodal cord, a tubular nerve cord, and some type of gill. In this video, I'd like to talk about three categories of fish. The jawless fish, the fish that have flexible bones made of cartilage, and the bony fish. Jawless fish are in the group called agnathans. They lack paired fins, an internal skeleton system, and they have a strange circular mouth. Common examples include the hagfish and the lamprey. Fish that have flexible bones made of cartilage are called Chordates. The most common examples are sharks and rays. This group of fish contains some very fierce predators. Our bones are in the group called Osteichthyes. They have paired gills and scales. They're found in both fresh and salt water. Here are some common examples. Thanks for watching. Moo Math uploads.
Okay, just so you know, that guy actually pronounced a lot of the words incorrectly, but we're just going to move on. All right, final slide for today deals with amphibians. Amphibians, if you take a look at the word amphibian, amphibian actually means land and water. Okay, so, during World War II, we had amphibious assaults. That just means that, we attacked from land and sea, right? So anyways, amphibians spend some time of their life in water and on land, and when they live on land, they're still tied closely to water. They don't go too far from water. So some key characteristics about amphibians is that their bodies do change as they grow older, especially when you think about a tadpole and how it turns into a frog. Yeah, the tadpole is drastically different from what a frog looks like. The skeletons are made of bones, and they do develop legs for movements. Okay, they lay eggs with no protective covering, and so as a result, they have to lay them in water. And so that is why amphibians are still tied to water. Another reason is that some amphibians breathe through their skin, and they have to keep their skin moist in order for diffusion to take place. So that's another reason why amphibians tend to be close or live, kind of in swampy, wet land areas. So examples of amphibians: frogs, toads, and salamanders. So I'm going to finish 11.3 tomorrow. I'm going to talk about birds and reptiles and mammals, and then basically conclude chapter 11.